Hey guys, my name's Amir and today we're going to be looking at acceleration, velocity and displacement graphs and easy ways to remember how they work. So we're going to be looking at the acceleration, velocity and displacement graphs. So before we look into that, let's just make sure we know what each of these are. So we have acceleration. Now acceleration, I'm going to use the units to help you remember what they are. So this is the rate of change of velocity. So it's like meters per second, or in other words, meters per second squared. Then we have velocity or speed. This is just meters per second. And then we have displacement or distance. So we have displacement, and that's measured in meters. So these are just the units for these. And I like looking at the units because it can actually give you a lot of information on what's going on. So we have the displacement, which that should be easy to understand. It's just the distance you've traveled from the origin. Now the velocity is a rate. So what does a rate mean? It means how much something is changing by with respect to time. So if our displacement is changing by 5 every second, then our velocity will be 5 meters per second. Okay, the acceleration is the hard one, but you can always think of it as it's the rate of velocity change. So just like how velocity was the rate of displacement change, acceleration is the rate of velocity change. So that's why it's meters per second every second, and when you do some math, that simplifies to meters per second squared. So make sure you understand what these three are before we move on to how to explain the graphs that are represented by these values. So we're going to look at the displacement time graph, the velocity time graph, and the acceleration time graph. And I like to think of it as levels. So you can think of this as like the base level, level 1, and then you can maybe think of this as level 2 and maybe level 3 as well. And that might help you understand the next section, which is a quick way to remember the graphs for these kinematics values. So I'm going to show you now a table that you can use to remember the significance of the area under the graph and the gradient of the graph. We have our three types of graphs. So we have our displacement graph, we have our velocity graph, and we have our acceleration graph. So these are the types of graphs. And we want to know what the area under the graph gives us, the actual graph itself gives us, which is an easy one, and the gradient, what the gradient gives us. So I'm just going to fill this in, and you can memorize this table if you like. So the displacement graph, the area under it doesn't give you any useful information. The actual graph itself shows you its displacement. The gradient of it tells you the velocity. Now for a velocity graph, the area under it shows you the displacement. The graph itself shows you the velocity, and the gradient will show you the acceleration. The area under an acceleration graph will show you the velocity. The graph itself will show you the acceleration, and the gradient won't be anything useful. So you can actually notice a pattern here. So remember how I said, think of displacement as a level 1, velocity as a level 2, and acceleration as a level 3. Then what the area under the curve does, it means go down one level. So we have a velocity graph, which is level 2. The area under the curve means go down to level 1. That's what it shows. And we can look at the gradient. So gradient means go up a level. So you can think of this as go down a level, and the gradient as go up a level. And the acceleration will be one level up from level 2 to level 3, and the area underneath for an acceleration graph would be one level down, just level 2. The graph itself shows the acceleration, and the gradient would be like level 4, which is not covered in most of the syllabus. So you can choose to memorize this, but I don't like memorizing things. So I'm going to show you a way to help you remember them if you do forget, and it is using units. So we're going to start with a velocity time graph. So a velocity is measured in meters per second, and time is measured in seconds. So let's just assume a random graph like this, straight line. And now we're going to look at the area under the curve. So the area under the curve, let's say, at a certain time, if we wanted to know this area here, how do we work that out? We multiply this distance by that distance. Pretty straightforward. So now let's look at the units. What happens when we multiply these two things together? So what we're getting in terms of the units is this value is going to have a unit of meters per second. And we're going to multiply it by something, the time axis, which has unit seconds. So if we look at this, so this is the area under the curve. If we multiply these out together, we end up with meters, right? And meters is the unit for displacement. So if you have a velocity time graph, you can see the area under the curve will actually give you the displacement. So that's one way of remembering it. Okay, now let's look at the gradient. So let's say if we had a slightly different curve instead that had a constant gradient. So our curve was something like this. Now we want to work out, how do you work out the gradient? So if we were to work out the gradient, we want to do rise over run. So hopefully you guys remember gradient equals the rise over the run. So now if you look at the units for the rise are going to be meters per second. And the units for the run are going to be seconds. So now we have meters per second divided by second, and if you do some math, you can see that this is meters per second squared. And what does this represent? This represents acceleration. So if you do forget that table, then what you can do is you can just quickly look at the units, and if you're working at an area, you multiply the units together to see what it gives you. And if you were trying to find the gradient, see what the gradient gives you, then you just divide the y-axis unit by the x-axis unit, and you can see what value it's supposed to give you. So this works with all sorts of graphs: the displacement time graph, the acceleration time graph, and the velocity time graph. And it's really useful for answering questions relating to these graphs. I hope you enjoyed that video. Tag your friends that don't understand acceleration, velocity, and displacement graphs. And remember, you can ask us questions anytime and we'll answer them for you. Thanks.